All right. Yes.
Is the arrow down showing that it's
Yes, that's precisely.
Yeah, but I need to show that in my equation.
Yes.
That's part of it.
Yeah, well, that's a huge part of it. Yep. So what we're showing here is that when we put this in water, it completely dissociates. That's what we're showing here. This is very similar to the dissociation equations that we had done before. We're just showing the end result. Same thing with the lead nitrate. We're just showing that that completely dissociates into a lead and 2 nitrate ions. But, and maybe we did do a drawing or started a drawing. Okay? In which case, we possibly had some, I hate brown. Maybe we had some potassiums floating around. Some chlorides floating around. Some lead floating around, and looks like a couple of nitrates floating around. Okay? Those things are all floating around. I think I was asking the question, what's going to happen when a potassium and a lead come near each other? Nothing. In fact, they'll probably repel each other. What's going to happen when a chloride and a potassium come next to each other? Nothing, because remember, they completely dissociate. What's going to happen when a chloride and a nitrate come next to each other? Nothing. They'll probably repel each other. However, what's going to happen when a lead comes near a chloride? They are going to have a strong attraction towards each other. They are going to form the solid lead to chloride and precipitate out, leaving the rest of these ions floating around in solution. Yes?
How can you tell which
Because we know that all potassium salts are always soluble. We know that all nitrate salts are always soluble. And if, in this case, the AP used to make you memorize that. See, most chlorides are also soluble, but one of the exceptions is lead chloride. They used to make you, this is what someone asked me earlier today, they used to make you memorize that. So now the question would be probably phrased in such a way that when these two substances are mixed, a precipitate forms. Okay? So we know a precipitate forms. We know that it's not going to be this for all the rules that you had to memorize, the 4 that you had to know. Okay? Which means then it would have to be that.
So just because something that's not soluble doesn't mean it's precipitate, because it didn't dissociate. It has to dissociate, then come together with something else to become a precipitate, or something that's not soluble at the end of something is a precipitate.
Anyone?
That makes sense in my brain. Here, I'll try it again. I'll try it again.
Good. Trial 2.
Okay. So if something's not soluble, it's not dissociating.
It's not dissociating, but okay, we'll let that.
Right.
If it's insoluble,
Right.
it's
insoluble at the end.
it's not dissociating.
Right. It's this thing. That doesn't mean, what is that thing? That doesn't make it a precipitate.
Oh yes, it does in an aqueous solution.
But it can dissociate and associate with something else. Okay, hang on. Okay, the potassium chloride is together.
Yes. No. Well, no. The potassium chloride initially is in solution,
Yes.
so it's dissociated
Yes.
automatically.
Yes.
As soon as you see this, that means it's in solution and it's dissociated.
Yes.
Okay.
I'm saying for something to be a precipitate, it doesn't have to go through the process of dissociating and associating with another thing.
I'm not entirely sure what you're asking, so what I'm going to have you do is ask me sometime outside of this arena right now, like tomorrow morning or after class. Okay? Moving on, because I don't want this discussion confusing anyone else. Okay, so Something that doesn't dissolve in water. It's an ionic compound that doesn't dissolve in water.
Okay.
We are going to find out, however, in chapter 17, that this is going to precipitate, but there will still be a really, really tiny amount because it's going to be an equilibrium scenario that is dissociated. But for now, for all intents and purposes, it dissociates.
It's good. I dumped it down. It's super good.
Last try.
All right. If it stays the same from the beginning to the end, is it a precipitate? Wait, does it precipitate? No. If it's
Let me finish. And lastly, is everyone, I can get rid of this? I do want to point, and I'm not going to get rid of it. The last piece is the net ionic equation. Yes? This might cover everything, Gracie, that's been going on for the last 6.2 minutes. The net ionic equation only shows the species that actually change. So let's walk through this. What changed? Did we see any potassium chloride in the solution? No, because it all dissociated. Did we see any lead nitrate in the solution? No, because it was all dissociated prior to us even getting to it. Did we see any potassium nitrate in the solution? Do we see any lead chloride in the solution? Yeah, it's going to be a solid that eventually works its way and settles on the bottom as a precipitate. What's the only species that were involved in that? Anyone can answer this. Say this again. The lead was involved, and the chloride were involved to form the lead chloride. There are the only things that we need to put on here. Okay? So the net ionic equation is going to be, the way I've currently got it written, 2 chlorides plus a lead 2 ion producing lead 2 chloride. Boom. That's the reaction. At some time here in the future, I'm hoping not too distant future, that your brains are going to be able to do this. I'm going to say, hey, we're going to take some potassium chloride, we're going to react it with some lead 2 chloride, write a net ionic equation for that process. Hopefully your brains will be able to take this and come up with this without having to necessarily go through all of this. It's going to take some practice and some experience. But technically, I look at this in my, time out, my bad, sorry about that. Your brains need to go from here to here quickly without having to go through all of this. Just relax for a second. I'm letting that sink in, okay? You guys see where I'm going with that? I mean, I look at this and go, oh, lead chloride precipitates. Here's a net ionic equation. Do-do. Now, I've been doing this for a few decades longer than you have. See, I can speak in terms of decades. You're working on your second decade. I'm going to go here first. Go ahead. I'm sorry, what? Dissociation. Let's get rid of that other syllable. There's no need to discuss dissociation right now. Yes?
Okay, so this is kind of stupid, but precipitate.
I've noticed that every time you ask a question, you start it with that phrase. Go.
Precipitation reactions only happen in a double replacement reaction, right?
By golly, she's on to it. What you would have called we would have called last year a double replacement reaction. We've now taken, and we're going to actually make three things out of that. One of them is a precipitation reaction. Another one we did last year, even though it's technically a double replacement reaction, one of them ended up being an acid-base neutralization. We started the process of calling it something else last year. And then there's something else called metastasis, which means nothing happens. I'll show you that here in a second. No, you just helped like five people, maybe 6. How many people did she just help? Okay. Okay, so again, ultimately, your goal is to be able to take this and in your brain, or I don't really care how you do it, but the faster you can do it, hopefully that's in your brain, get to this. I'll give you a couple of examples here in a second. Okay? All right. Oh, and to answer Gracie's lingering question, then what the heck are these things doing? We actually have a name for them. Those are called spectator ions. Okay? Why are they there? Okay. That's true. But there's another analogy that I like to bring here. Does anyone recall going to, maybe some of you guys didn't. Really, I hope you didn't. Did anybody go to a middle school dance ever?
Yeah. All the boys are in one.
Great. Emma, how did you get there? Time out. What? Your mom took you to the dance and did what? Dropped you off. That is what this is doing. It is bringing chloride to the dance, dropping it off so it can go hook up, or sorry about that, hang out with Mr. Lead over here. What? I never say anything school inappropriate. Right. No, I said the chloride. So anyway, are you guys getting more? Now here's the thing. Could this easily have been sodium? Could it have been your dad? Bringing you to the dance. Could have been. Could it have been, let me see. Could it have been magnesium, your brother? The answer is yes, it could have been. All these things are doing are bringing the, would you stop? All these things are doing are bringing the reacting species to the reaction. Does that make any sense? Spectator ions. The other way to look at that is they're still spectating. They're just hanging out. They're not doing anything. They are not contributing to the reaction other than bringing it to the solution. All right. So we have spectator ions. We have precipitates. Because you do currently need a little practice with writing all of the molecular, the complete ionic, and the net ionic. On the next page, should be page 6. I might be wrong. It might be at the bottom of page 5. Oh, well, I'm way off here then. Can I see that? Yeah, top of page 6, Russ. Yeah. Mm-hmm. Okay.
Yeah.
Oh, yeah, okay. Anyway. Is it aqueous nickel 2 chloride and sodium hydroxide? Okay. So it says aqueous nickel 2 chloride is mixed with aqueous sodium to form an insoluble product, or in other words, a precipitate, okay? And an aqueous solution of another salt. Write a molecular equation, a complete ionic equation, and a net ionic equation. So do all 3 types of equations. I am going to, here in a second, while you guys are doing that, I'm going to kind of create some other ones to practice getting better at this without going through all those parts.
You told me that a precipitate was one that, like, dissolves.
No, no, I never said that.
Okay.
I may have misinterpreted a question that you said.
That's fine. I was just, like, confused. I was like,
Which one?
Is that the precipitant?
Yes. However, well, let it go now. So go from this, do the complete ionic also.
Oh.
But that's good that you're able to do that. Look at how you wrote the formula for the precipitate, though. That's the only thing I'm going to say. I'm hoping that you guys were picking the nickel 2 hydroxide as the precipitate. No. Can't believe Madeline still just doesn't want to hang out in here with everybody. If I were her, I would. She just hangs out there. Oops. How could I do? I could try that 10 times and not be able to do that again. Because they don't have enough charge. Remember we talked about coulombs? Yeah. They just don't have enough charge.
Okay.
What was it again? Nickel what?
Nickel 2 chloride.
Chloride
And
sodium hydroxide. And remember, they're also of all the ions, they're the largest from that side of the periodic table.
Yeah.
Remember that the distance piece was also part of that. Yeah.
Q1.
Yep. Right. Yes, precisely the same. All right, so you guys should have that as your products. It doesn't matter which one of these you write first, whether you write the nickel hydroxide first or the sodium chloride first. You guys get that, right? Okay, 2 plus 3 is 5. Good, thank you. No one said 6. 3 plus 2 is 5. It doesn't matter. Okay. And so doing the complete ionic, we get a nickel ion plus 2 chloride ions plus a, boom and boom, plus 2 sodium ions and 2 hydroxide ions, yielding 2 sodium ions plus 2 chloride ions plus a nickel hydroxide precipitate. Yes? I know. So remember, last year we put S for solid, L for liquid, G for gas. Always goes after it. Okay. And finally, obviously, the reacting species are the nickel ion and the hydroxide ion. So and there we go. Okay. Let's try a couple that I'm just going to give you the reacting species. Okay, I'm going to give you a pair of substances. They're all going to be assumed to be in aqueous solution. You are going to see if you can write a net ionic equation directly from the pairs of aqueous solutions. Okay? All right, here we go. I'm making these up as I go along. So let's go with, here we go. And well, no, I'm not going to say that. Sorry about that. Okay, there's the first one. I'm trying to do this in terms of what the AP is looking at. There we go. Try those three. See if you can come up with a net ionic equation for each pair. Oh, is your hand up? Does this help? Okay. So how's the aluminum carbonate? No, I was talking to Gracie. Chloride, sorry about that, aluminum chloride. Pretty good? Oh, I know. Try to do this without writing. If you screw it up, you screw it up. It's not that big of a deal. Try to do this without writing either a molecular or a net ionic equation. Morgan, just out of curiosity, is that, I don't even know what these things are called, megaphone in your way? Okay. What? Check with your colleagues. There you go.
It's like hard because I don't know how many of each there are. You know what I mean?
Yes and no.
Like what the coefficients are.
I know that. I know what you're asking.
What'd you get? Can you tell me if I got this one right? Or no? Are we gonna talk about it tomorrow?
We'll talk about it tomorrow. All right. Let me shut this down. All right, we have a